Okay, this is 15.4, number 3. We're looking for the area of the part of this plane that lies in the first octant. So I know it has to be a finite area, otherwise, if it sort of trailed off and went off forever in the first octant, then the area would be infinite. So let's figure out where this guy is. So first, let's solve it for z. So z is going to be equal to 1 minus x minus y. And when that's equal to 0 is when we're in the xy plane, and you'll notice that y equals 1 minus x. So that's a linear function that goes between 1 on the x and 1 on the y, because when x is 0, y is 1, and when y is 0, x is 1. So it's a line that straddles 1 to 1. And that's where this guy intersects the xy plane. When x and y are both 0, we're at the origin, and of course z is 1. So now we know the shape of it. This is the shape of the plane in the first octant. So let's go ahead and find the area traditionally, and then we'll go back, and because we know the shape, we can actually find it. We can find it by using its dimensions. Okay, well, y going from 0 to the function, let's go ahead and use pieces that look like this. So we'll integrate x between 0 and 1. So 0 less than or equal to x less than or equal to 1. And we'll integrate y up to the line. So y will go 0 less than or equal to y less than or equal to the line 1 minus x. So this will be the inner integral, this will be the outer one. What are we integrating? Again, we're integrating the square root of the function fx squared plus fy squared plus 1. So the partials of this, z with respect to x is -1, and z with respect to y is also -1. So these squared are just 1 plus 1 plus 1, or radical 3. So here's our integral. It'll be x on the outside, 0 to 1, integral from 0 to 1 minus x, and that's square root of 3 dy dx. Okay, and when you do all this, this isn't a particularly hard one. You get radical 3 over 2 as an answer to the double integral. Well, let's go back over here and look at it geometrically. This guy is an equilateral triangle whose sides are hypotenuses of 45, 45, 90 triangles with legs of length 1, so it's radical 2 on each side. And if I draw in an altitude, that makes a 30, 60, 90 triangle, where this is radical 2 over 2, and this is radical 3 times that, so that would make radical 6 over 2, radical 6 over 2 for the altitude. So now we can traditionally calculate the area as 1/2 base times height. That's 1/2, the base is radical 2, the height is radical 6 over 2, so that's radical 12, or 2 radical 3, or radical 3 over 2. So there it is.